Hey, welcome my math friends. Hey, I'm just working on these problems from the book here from section 7.2. And I'm looking at problem number 28. So it's a little group of them, 28 through 31. And it's asking us to find, using the periodic properties of sine and cosine, find the exact value of these funky looking angles, right? So what they're doing is if you notice you're doing, the numerator is a lot bigger than the denominator. So they're doing angles that are bigger than 360 degrees. So first of all, just quickly recall what an angle is, how you make an angle. If you remember, angles start when you have your first ray on the x-axis, and then you rotate that same ray counterclockwise, right? And that's 90 degrees, that's 180 degrees. Or in radians, of course this is all in radians, pi is 180. So 90 would be half of that, pi over 2. 270 and then 360 would be 2 pi. So, and then it just keeps going around and around. So what that means is like an angle, let's say that's 30 degrees, is also going to have the exact same sine and cosine as an angle that's, I'll change colors, as an angle that started here and went all the way around and then stopped at 30. So those two angles, one of them, that red one would be 30 plus 360. And that's the same cosine. It's not the same angle, remember, because it's a little bit different because one angle we rotated all the way around first. But nonetheless, the sine and the cosine is going to be the same for whether you're using the black angle, which would just be straight up 30, or the red angle. They're going to be the same because they both are going to cross that unit circle at the same coordinate. So what they're doing is they're giving us a little problem here. I'll erase that. And the red doesn't erase so well. So they're giving us a problem with improper fraction, numerator is bigger than denominator, and we have to figure out how many times did that angle, that ray, rotate before it ended up wherever it ended up. So how many times did it rotate and where is it ending up? So all you really have to do is keep in mind that every 2 pi, that's one complete rotation, that's 360 degrees. So I'm going to turn this into a mixed fraction. So 13 divided by 6, 6 goes into 13. This is the same as 2. So 2 times 6 is 12. And then 13 minus 12, there's 1 left. So it's the same as 2 1/6 times pi. Or just pi over 6. You could write it that way. And now remember in your mind, what is pi? Well, pi is equal to 180. So in terms of angles, that's going to be 180. And not in terms of angles, in terms of degrees, that's going to be 180 divided by 6. So that's going to be 18 divided by 6 is 3. So that's 30 degrees. So it's going to be 2 complete rotations, but then you're going to end up at 30. And all you really care about is you want to find out where you ended. That's the key. Now that you know you ended up at 30, you can find the sine of 30, which you've memorized. I think I memorized that. The sine is the y value. So if I'm remembering my unit circle, pretty sure that the y value is 1/2. And then the cosine of 30, I believe, is square root of 3 over 2. I hope I remembered that right. I haven't done a lot of these problems yet, so I haven't completely confident about my memory. But hopefully that's right, so you can check that out. So that's the way you're going to do that. I would take the improper fraction, I would turn it into a mixed fraction. The whole number is how many times it rotated around. We really don't care too much about that. We just want to know how much is left, because that's where the angle is going to end up at the very end. And then you can find the sine. It's always going to be 30 or 45 or 60 right at the very end. Almost so already. Or it could be like 135. And then you have to figure out what that's going to be like. Well, that's going to be like 90 plus 45 more. So then that's going to be a 45-degree angle, but it's going to be over in that other quadrant. So you're just kind of working with that, drawing pictures. Please, people, draw a picture. If you just keep it all abstract in your mind, it's hard. You're starting to juggle a lot of different things in your head all at once. And in the beginning, even when you get old like me, especially when you get old, draw pictures. If you draw the picture, it will help you a lot. All right, have fun with those problems.